Okay, we are now recording. Everyone can still see the slides?
Yes, you're good.
Fantastic. All right, thanks for joining everyone, and welcome to our next training recording session as part of the workshop series for the Climate Resilience Roadmap for Ontario Municipal Infrastructure Systems. And this was developed by the Regional Public Works Commissioners of Ontario, or RPWCO. My name is Shelley Hazen, and I'm a climate change specialist with Savanta GEI. And today I'm joined by Glenn Milner from the Climate Risk Institute. We're also joined today by RPWCO Climate Change Subcommittee members from the City of Thunder Bay, Windsor, Ottawa, and the region of Durham. And we'd also like to thank Rambo Consulting for their contributions to the development of the RPWCO roadmap. So this is our third training session on undertaking a climate scenario analysis. And if you haven't already done so and would like to obtain an overview of the entire process of the RPWCO roadmap, we recommend that you go back and listen to the first training session. So that provided a really great introduction to the roadmap and summarized each step of the process. Training session 2 covered steps 1 and 2 of the roadmap, and that was all about engagement and setup and taking stock of your municipal asset inventory. So today our training session aligns with step 3 of the roadmap, as you'll see highlighted on this slide. Now, before you start step 3 of the roadmap, there are a few prerequisites for your municipality to undertake. So by this stage, you should have formed a project team and advisory committee. You should have identified stakeholders and an engagement approach, as well as documented municipal and key assets in the community. You would have already obtained GIS data and evaluated data completeness and confidence, and aligned risk assessment themes with your municipal services. So all of those tasks actually align with steps 1 and 2 of the roadmap, and that was provided in the previous training session. So what will you learn in step 3 of the roadmap? Well, step 3 provides guidance on identifying the municipal applications you hope to use climate data for. It can help you determine what climate scenario is the best to use for a precautionary approach in your planning. It will provide guidance on when to obtain climate data historically and in future time periods. And it's going to introduce you to the recommended climate data portals that are going to inform your risk assessment. And I'm going to pass it over to Glenn.
Perfect. And so before we jump into the big details of step 3, we wanted to provide a complete overview of the different components because undertaking a climate scenario analysis can be quite involved and can be quite complex. So what this slide allows you to see is the different steps of the components along the process that are important to capture. So if you start from component A, the roadmap allows you to determine if the municipality that you are at actually has climate projections and how old they are. Sorry, Shelley, I'm just trying to pull up the slides back here. There we go. So just returning to step A, the very first component of step 3 is to identify if your municipality already has climate projections and how old those are. We'll walk in through each one of these in greater detail in the coming slides, but once you've identified if you need projections or how old they are, you can move on to scoping that climate information in terms of what you hope to use it for, and ultimately selecting a climate data portal. From there, we recommend it's important to characterize your historical climate conditions and the impacts that have already been observed or experienced in your jurisdiction. And again, we'll walk you through why that's important and how you can kind of think about that as part of a trends report or scenario analysis. Component D, as part of step 3, is to ultimately select a scenario you'd like to proceed with, the time horizons of analysis, and ultimately obtain your projections. From there, the RPWCO roadmap provides guidance around how do you analyze those projections to inform risk assessment, and then ultimately take stock or provide an inventory of those trends in a nice tabular format. And then component F is dissemination and sharing that data among municipal staff. So if you go to the next slide, we just wanted to begin step 3, the training session, with a bit of a climate 101. And so the next 3 slides are just going to be a bit about the science behind the data that's typically involved in the climate scenario analysis component of risk assessment. And this slide shows the advancement and the effort that has gone into global climate modeling over time. And so you'll see the acronym IPCC on this slide several times, and that stands for the Intergovernmental Panel on Climate Change. And they are really the international coordinating body that is responsible for synthesizing the climate science and the best practices around adaptation globally. And you can see that they've been working on climate modeling since the early 90s, and the climate model resolution has been dramatically improved over time with the effort and the resources that the global community has dedicated to it. So if you go back into the 1990s, climate model outputs actually were coming out around 500 square kilometers, so very, very coarse. But up into 2013, we actually see climate model outputs around 87 kilometers squared, which is much more refined and more local. And this can actually be downscaled even further. So next slide. So I mentioned it can be downscaled further. The image on the left on this particular slide shows global climate model output at that 88 square kilometer resolution. And there's opportunities to downscale that even further, particularly for areas that have local influences of lakes and that are important to capture. So the middle image there shows a 50 by 50 square kilometer regional climate model that has been used to downscale. And the image on the right shows a 25 by 25 square kilometer regional climate model. And there are opportunities to downscale this even further statistically to 10 by 10, with the ultimate intent to equip decision makers with information at scales that make sense for their decision-making needs, such as municipalities. So next slide. But we wanted to also caveat that it's important to understand what climate models can and cannot provide us as part of this information and these analyses. So can we model surgical storms like this one? And this is actually an image of July 8th, 2013, and it is a radar-derived image from NOAA out of the States, and it shows the total accumulated precipitation in inches and how surgical some of these convective storms can be. And so if you look over Rexdale, that area of yellow, it's showing around 8 inches of accumulated precipitation over the course of this event. And it's quite important to understand the role of modeling for climate science in relation to what we actually experience in these surgical storms. And so the key message here is that climate models cannot predict with great confidence events like this, but they are able to tell us how extremes may be changing over time. And they can characterize those extreme precipitation events slowly and over the course of future time horizons. So understanding the pros and cons is important prior to diving in to an analysis and a risk assessment. So with that, I'll hand it over to Shelley to continue as part of the Step 3 components.
Now, you heard Glenn talk about scoping your climate information needs in his overview of Step 3. So this is a really important sub-step of the overall process of Step 3. So climate data and scenarios can be used for various municipal applications. And depending on that application, the approach to incorporate climate scenarios into municipal initiatives is going to differ. So quantitative climate scenarios are often leveraged for things like impact modeling to inform infrastructure design and program thresholds and for risk assessment. Whereas when we're talking about qualitative climate scenarios, they can be used to inform policy wording updates, community education and awareness raising, and in things like conveying stories or sharing the message of climate change to council. So if you consider the snapshot of the table on this slide and how it might help you identify what type of climate information you might require. And as you can see from the table, not all municipal applications or initiatives actually require that detailed quantitative data to inform their work. But there are some particular applications that the type of climate information can really vary, and it depends on the level of detail that you're going to be needing. So as an example, risk assessments can involve the use of quantitative time series to run models and then to produce future hazard mapping. And this aligns with undertaking a detailed pathway, and we'll get into more information about that in the coming slides. So on the other hand, a more simplified methodology that might involve interpreting changes in future average conditions and then estimating risk using a scale. And this more aligns with what is called an accelerated approach. And you're going to be learning more about that in this slide and also in Step 4. So it's going to provide you guidance on assessing and prioritizing your projects later. And more generally, if your municipality intends to use climate information and scenarios to accomplish multiple applications that are listed in this table example, so policy wording updates or running model impacts, it's probably valuable to obtain a combination of both quantitative and qualitative information in order to enable your ability to inform numerous initiatives across your municipality. And you should always ensure that the advisory committee and the appropriate stakeholders that you have categorized in step 1, make sure that they're involved in scoping the climate information needs. And to help you identify the preferred approach for your municipality and whether you should undertake an accelerated or a detailed pathway, you're going to refer to activities number 6 and 7 in Appendix 1 of the roadmap. Now, based on the path you select, an accelerated or detailed, it's recommended that you use one of the following climate data portals. However, it's important to note that these are recommended or were recommended based on the date that this guide was published. So new portals may be developed or released and updated with additional information. So as you're using this roadmap or you pick it up a year from now, make sure that you're taking a quick scan for any Ontario or Canadian climate data portals, just to avoid missing any of the latest information that might be out there. So if you're undertaking an accelerated pathway, you're going to use the Climate Data for a Resilient Canada portal, and this is shown on the left side of the slide. And this portal uses an ensemble of 24 global climate models, or GCMs, and this is a term Glenn used a few slides back. And these are statistically downscaled and bias corrected in this portal. Now, if you're undertaking a detailed pathway, you're going to use the Ontario Climate Data Portal. And this was developed by York University. And just to note, this portal does require more technical expertise, but it also incorporates regional climate models that are dynamically downscaled, and that may capture lake effects, for example. So this portal is more of a super ensemble, and it has 209 GCM and regional climate models, RCMs. Now, Activity 6 provides you important educational information surrounding climate information and data and details on these two climate portals that we've noted here. And we'll be providing additional guidance on selecting between an accelerated and a detailed pathway in the coming slides. It's important to realize that the data source used to obtain climate projections matters. So the extent to which lake influences are captured really varies based on the approaches used by the modelers. So a recent study by the Great Lakes Integrated Sciences and Assessments, known as GLISA, identified that only 18 of the 55 global climate models actually captured the Great Lakes as dynamic in nature. So when in doubt, it's okay to reach out to Data Portal's creator and ask those clarifying questions about what is and is not captured in their models. And make sure that your choice of portals is really meeting the needs of your municipality and your data needs. So to help you identify the preferred approach for your municipality and whether you should be undertaking an accelerated or a detailed pathway, as I mentioned, you can refer to activities number 6 and 7 in Appendix 1. We mentioned a few slides back that Activity 6 specifically provides important educational information surrounding climate information and data and the two climate portals, whereas Activity number 7 is going to help you identify what climate parameters are currently and typically available on an open source government data portals. It also helps you or prompts you to consider if you might need those various climate parameters and which ones are actually going to be required or which ones you might need to have certain quantitative analyses for in the future. So we really recommend that you're going through all of these activities that are supporting in step 3. Now, if you select an accelerated path, or you will select an accelerated path, if you have the ability to leverage existing municipal climate trends from within the past 5 years. So make sure that you ask around to various departments if you're unsure if these trends already exist. You wouldn't want to be repeating something that's already existing that you just don't know is out there. So make sure that you're asking around. Now, if open source government data portals are suitable for all of your climate information needs, you're going to want to stick with the accelerated path. And if you're only interested in qualitative or semi-quantitative risk scoring based on expert judgment rather than, say, hazard modeling, again, you'll stick with that accelerated pathway. Now, you'll need to undertake a more detailed pathway if you require climate parameters that are not readily available on open source government data portals. And Activity 7 can actually help you determine whether you do or do not need open source or more quantitative analyses. And if you require external expertise to analyze or derive locally customized data, such as wanting to incorporate lake effect conditions. You'll also use a detailed pathway if you want to run quantitative models to estimate the extent of a hazard or undertake a detailed risk assessment. So those are the two pathways, the accelerated and the detail, and there's more information and guidance around how you can choose between the two in the roadmap. Now, once you have an idea of what you hope to use the climate information for and what climate data portal you're going to leverage, it's important not to skip over the characterization of historical and ongoing climate conditions and impacts across your municipality. So this is an important component of developing climate scenarios, and it really enables the comparison of future trends with historical or observed data. And historical climate characterization often involves obtaining observed climate data at local climate stations, and ideally with a minimum of 30 years of data, and then analyzing average conditions and trends through time. Also compiling anecdotal evidence via media articles or maybe stakeholder expertise, just based on observed experiences. So there are two important questions that you'll want to ask at this stage as you're going through the roadmap. What impacts have occurred in your municipality, and what climate-related hazards does your municipality face that generate complaints or costly repairs? So many climate data studies focus more on future trend analysis rather than historical characterization. But the latter is really critical towards understanding and incorporating concepts such as lake effect precipitation patterns or spatial variability across your municipality's geographic area. It's also important for things like significant topographic features that need to be accounted for in your analysis. These are things like Niagara Escarpment or the Oakham Ridges Moraine, for example, here in Ontario. Also for the quality and coverage of historical observational records across a geographic area. So upon completion of the climate data analysis, it's a common approach to compare future trends alongside changes with those that are already observed, and then you sort of weave it together or interpret how climate change impacts projected into the future may actually manifest based on historical knowledge. So we're going to share a relevant case study with you from York Region. Now, you may remember from the first training overview session that we introduced how case studies and real-world examples are peppered throughout this guide along each step of the roadmap. So an important component of developing climate scenarios for use in a risk assessment involves compiling and characterizing historical climate impacts, just like we spoke about in the last slide. So in 2016, York Region undertook a comprehensive literature review and a series of stakeholder interviews to produce anecdotal evidence of locally relevant historical impacts. So they wanted to document all of this information. And the review actually involved identifying climate impacts in reports, in media articles, and just based on stakeholders' experiences, all the way back to 1985 to 2015. They identified the year, the season, the event that occurred, and any location or impact details. So events ranged. They included extreme rainfall, heat waves, tornadoes, hail events. There were some ice storms, and any shoulder season sort of extreme variability, among other events. So this is just an example of a relevant case study, and if you'd like to learn more or read more about it, it can be found on page 29 of the roadmap. Now, following the completion of steps 3A and B, it's now time to obtain future climate projections. And Activity 8 in Appendix 1 is going to provide you with a process to start to document climate impacts and hazards of concern for your municipality. It'll also help you identify and confirm specific details prior to downloading climate information, because there can be a lot of data to download. So you want to make sure that you're selecting the right information or the right variables that are key for your municipality. And don't forget, like we've been saying, that anecdotal evidence relating to historical impacts and damages, it can be a really valuable resource. So news articles, staff experiences, you should also be documenting that information. Now, Appendix 1 is also going to assist you in documenting the climate forcing scenario of interest to your municipality. So the roadmap recommends the use of a business as usual scenario in your risk assessment. Now, in RCP 8.5, this takes a precautionary approach at estimating climate risk. So if your municipality is interested in going above and beyond or wants to compare different future levels of risk, you can also use an additional scenario, such as a moderate emission scenario, and that is an RCP 4.5. With regards to selecting a future time horizon, it's really critical to understand that uncertainty increases the further projections are being used out into the future. So extreme rainfall projections for the end of the century out to 2100 are less certain than those over, say, the next 2 decades or even out to the 2050s. So regardless, it's recommended that climate data be obtained for all future time horizons. So it's short term, midterm, and end of century. And that generally is the 2030s, the 2050s, and the 2080s, in order to provide a foundation across all municipal departments. So optionally, if you're only be requiring climate scenarios and projections for infrastructure related projects, or say for one specific asset that you're scoping, you may just obtain climate data for a future time horizon that really aligns with that asset's design life. So for example, if you're just looking to use the climate data for stormwater infrastructure, you might just use out to the end of the century, the 2080s. Or if you're just looking for road infrastructure, you could just use, say, the 2050s. Now, the graph on this slide provides an example of this process of using average design life for a subset of assets. And the design life of an asset, it really varies depending on location, materials, updates. So this is just an example. But keep in mind that the further you go out into the future, the more uncertain climate models are. Now, the next sub-step is about analyzing the climate projections obtained to produce scenarios and then tailoring these to the level of detail required for your risk assessment. So, for example, do you need qualitative interpretation or a format such as a time series to run a quantitative model? So you may recall from steps 3A where you identified what specific municipal application is important for your process and tailor data towards that output. So typically for a risk assessment, this is a quantitative time series format, or in future average conditions to inform semi-quantitative risk estimation. Now, Activity 10 in Appendix 1 actually provides a template for you to consider displaying and summarizing the scenarios and analysis that you're going to be undertaking in this step. So using this template, it's essentially the beginning of a climate trends report. So you can use that to inform even secondary modeling studies as well as you go through this process. And as part of your efforts at this stage of the roadmap, it might be important to engage GIS staff and any municipal staff really who have experience in statistical data analysis or in identifying significant trends and mapping products. So the following are typically completed alongside a quantitative time series scenario and characterization. And these are things like GIS maps that display spatial trends and future averages, maximum or minimum temperatures, a comprehensive summary table that documents historical and future results for each climate parameter, direction trends for each climate parameter. So that's like an increasing trend. Is it decreasing or is it unchanging? And also a qualitative description that weaves together that change in local conditions into a narrative. So this particular step can be highly detailed or more accelerated, and that really depends on your municipality's interest but it should involve conveying advisory committee members and relevant stakeholders to discuss and confirm the climate data analysis results. And this could be done, for example, in a workshop setting or even through a series of meetings, just to familiarize stakeholders with the steps that have been completed to date, to bring people together to brainstorm and envision how the climate scenarios might be integrated into various applications or initiatives throughout the municipality. So it's really important that after you have all of this information, that you're actually going to be sharing it with people. So just another quick case study that you'll find in the roadmap on page 35, and this is around developing local climate trends across the region of Durham. So from 2018 to 2019, Durham Region updated their climate trend study to reflect the latest and best practices from international modeling community and to capture the influences of local features, which in this case is Lake Ontario. So the region and its stakeholders took an ensemble of dynamically downscaled regional climate models, or RCMs, to produce future scenarios for over 50 climate parameters. And this was using the business as usual, so that RCP 8.5 scenario. And the more moderate scenario, RCP 4.5, was also analyzed as secondary output just for reference. So in the RPWCO roadmap, this would be reflective of a detailed pathway that they undertook. And the region decided to analyze data across all future time horizons rather than only applying one of them in order to establish a foundation of scenarios that could be used for a wide range of municipal applications. Now, the last sub-step, and I touched on this in a few slides back, is really about the importance of disseminating climate scenarios and information among broader municipal staff. So first, you need to identify what type of climate information a municipal department or staff might actually require. And next, the narrowing the potential use of climate data to specific municipal needs can provide tremendous value. So you don't just want to come to the various departments with a statistical report with 50 numbers and say, here's the trends. Think, for example, of your finance department. What would they need, or how would they need to interpret this information? So historically, decision makers have found it really challenging to actually apply climate scenarios to inform adaptation-related decisions. So to overcome this, we suggest that you document any key lessons learned as part of the scenario development and the discussions from above in the previous steps. Now, you should summarize the updated climate scenarios in a short table, but with concise narratives. So identify things that people understand, like average changes, or will people better interpret things like trends or ranges of uncertainty? Maybe people will understand confidence levels better. So think of the way that you can actually present the data to the group and how you think they'll best interpret that data. And Activity 10 and Appendix 1 can actually help you with this. So then you identify staff leads who are interested or maybe responsible to learn more and consider ways that climate scenarios can actually apply to their work. So you'll recall that climate scenarios can be both qualitative and quantitative. So make sure that you are interpreting the data and applying it in a way, as I said, that department is going to understand. So prior to engaging across departments, you should consider identifying what type of information they're going to need. We brought up, for an example, finance. So how might heat waves impact seasonal and recreational programming? And could that lead to a loss of revenue? This is something that's probably really going to resonate with the finance team if you're talking about the impact and loss of revenue. So think about how you can tailor those stories. So finally, disseminate the information and train broader municipal staff on what climate change scenarios actually are and how they can be used. So as stated earlier, the practical use of climate information for municipalities and stakeholders is really diverse. So the types of initiatives that frequently involve collaboration between those that are requiring the climate data and those that are producing the climate data are often different. So depending on the application being pursued, this may require subsequent analysis or interpretation of the modeling or interpretation of the climate data output results. So just keep in mind who you're working with and if they'll understand all of this information that you're putting towards them. Great, I'm going to pass it over to Glenn.
Great, thanks, Shelley. So you may recall in our previous training session that we discussed a case study, conceptual case study from the City of Windsor. And this really was done and will be carried through some of these training sessions to demonstrate the logic of some of the different steps of the RPWCO roadmap, and to really demonstrate how it could be visualized and the outputs that could be achieved when one goes through the process. So in particular, a flooding scenario was identified to really demonstrate that particular hazard. And this example today will really focus specifically on the climate scenario or the climate data component. And in our next training session, we'll speak specifically to how the climate data can inform risk assessment and prioritization, of course. But just before I walk through the case study, just wanting to flag that this was a previous risk assessment that the City of Windsor undertook, and it was leveraged given the excellent information that was already available. But it is important to note that the results that kind of have been taken and have been adapted based on the RPWCO process are conceptual. And so the case study that we're demonstrating was completed without stakeholder engagement and should not be considered representative of actual risk across the City of Windsor. So it is for illustrative purposes only. But just by way of introduction, so in 2019, the City of Windsor completed a flood risk assessment along Riverside Drive East and some of the areas further inland. And we'll provide an example on the coming slides of where that is in terms of a map. But this was an area that has historically been protected by a dike system. And the intent or the purpose of this assessment was completed to evaluate the integrity of that existing dike system and particularly the surrounding assets, to determine whether the original design is appropriate under current and future flood levels. And so I'll walk through kind of how the climate hazard information informed that process. So on the next slide. So just in terms of additional context around the climate data side of things, Windsor used quantitative climate model information to estimate instantaneous water levels in 3 time periods: historical conditions, in 2030, and in 2050. And just in terms of additional rationale behind those particular selections, the 2050 period was selected to enable the planning of future dike improvements without committing the city to overly conservative design parameters in the short and medium term. However, it was important to recommend at that time that this assumption be reevaluated in the next 10 years as the climate changes and as we learn of what we're seeing in observational records. This was a fulsome risk assessment using the PIVC protocol, or the Public Infrastructure Engineering Vulnerability Committee protocol, which is commonly used and employed across infrastructure risk assessments in Canada. So next slide. So just demonstrating where this area is more specifically, for the purposes of the RPWCO roadmap example, conceptually, a series of assets were identified, and they are highlighted here on this map as red circles with numbers, ranging from the Little River Pollution Control Plant as number 1, a couple of pumping stations, Lakeview Marina, and some arterial roads. And our focus today as part of this training session will be on number 1, and we're going to really zoom into that Little River Pollution Control Plant and talk about how the climate data can interact to inform things like risk scenarios. And ultimately, we'll return to this map and all 5 of these assets in the next training session to talk about relative priorities geographically and spatially and how we make some of those determinations. So next slide. So additional details in terms of the risk assessment that was completed for the City of Windsor are very important to describe in a bit more detail here. As I mentioned, the risk assessment was completed to evaluate the integrity of the existing dike system for those time horizons, and hazard mapping was produced under current water levels, current 100-year water levels, future water levels, particularly for the future 100-year water levels. And this figure just shows a snapshot of some of those results. And you can see on the figure here, the areas in blue show the areas that are inundated with floodwaters, and the areas in green are above that particular instantaneous water levels. And we're seeing the increases through time as you kind of march from top to bottom and you see the areas that are increasingly being flooded under those more extreme water levels. But if you go to the next slide, this is important to characterize the impacts associated with infrastructure. So if we stay at the current water levels that were observed at the time of this study, the existing dike system is described as having, with some emergency modification, is currently protecting the properties to the south. But when you look at the 100-year water level under current conditions, some sections of the existing dike were identified to be exceeded. And zooming in on that asset that I mentioned on the previous slide, the Little River Pollution Control Plant, it is defined or described as being maybe impacted. And then if we go out to the 2050s at the 100-year water level, it's described and characterized as most of the dike would be breached and numerous properties are flooded. And again, that Little River Pollution Control Plant would or will be impacted at that level. So this is really helpful context and characterization to understand the potential risk scenarios to evaluate now and to plan our adaptation actions for once we have a good kind of picture of this information. So next slide. So this is where we wanted to emphasize the RPWCO roadmap process. And so kind of thinking about some of the context that Shelley provided from step 3 of the roadmap, and she mentioned activity number 7. And so this slide provides a visual example of activity number 7, which the purpose of this activity really is to help you scope the types of climate parameters that are most important to you as part of a risk assessment. So when you think about your jurisdiction, your municipality, and the types of climate events or extremes that have caused impacts in the past, this activity actually runs you through over 25 different climate parameters and identifies or asks you, is it important to scope this in based on the previous steps of the roadmap you've been following? So why might particular climate parameters be helpful is important to think about as part of this activity, but also are there additional climate parameters or information that may be important for your particular study? So in this case, water levels. And so it's important to also understand that accompanying this activity number 7, there's additional guidance in the roadmap, as Shelley mentioned, on pages 24 and 25 that helps kind of provide some contextual information before diving into this activity. So next slide. And so once you identify the climate parameters and you obtain your projections as part of a risk assessment, it's important to understand how climate information can actually be used to evaluate a component of risk and to actually derive risk scenarios. So this is just a very, very small snapshot of some of the climate data that you can consider for the Little River Pollution Control Plant. And so if we look at some of these numbers, you can look at total precipitation and the trend through time from historical into 2050s. You can look at the changes in extreme events, the 1 in 10 year, 1 in 100 year storm, for example, looking at about a 40% increase on average over time, looking at increasing water temperatures, and of course, increasing water levels at that 100-year event. And so what we recommend is look at the climate data, have some fulsome discussions around what are some of the scenarios that may be impacting the particular assets or areas in your scope. And if you go to the next slide, Shelley, we're going to provide one example high-level scenario of risk to characterize. So for example, if Windsor receives more precipitation, causing more flooding, particularly or perhaps in the winter time, this could overwhelm capacity at the Little River Pollution Control Plant. And as a result, that consequence may end up being excess or untreated water being released, causing environmental degradation or subsequent impacts. And so that's just one example of a qualitative risk scenario, typically of many, many others that can be identified when you think about the system and you think about it using some of the processes that are provided in the RPWCO roadmap and other risk assessment frameworks. But ultimately, in this case study, these scenarios need to be evaluated for their likelihood to occur. And this is ultimately what's carried forward into the next step of the roadmap, which is all around risk analyses and risk evaluation. But if you look at that equation at the bottom of this slide, you see the word likelihood there. Risk is equal to the likelihood and the severity of consequences. And so what this information around climate data really informs is that likelihood of occurrence and whether it's rare or almost certain. And there's many, many ways to kind of put some bounds around those ratings or those evaluations. And one example is provided in the RPWCO roadmap and on this slide, which is ranging from 1 through 5, using a probability-based approach. And so having these conversations in a workshop setting really can help kind of move through some of these risk scenarios that are tailored to your purposes. It can help you understand what might be rising to the top from the likelihood perspective, but recognizing that's only one component of risk. So next slide. And so I think with that, I'll hand it over to you, Shelley.
Thanks, everyone. Well, that wraps up our session on step 3. So we're actually going to open it up now for any questions that you might have.
Hi, it's Karina from the city of Windsor. I was just wondering, do I need to do climate modeling to implement this roadmap?
That's a great question, Karina. Sorry, I was on mute there. There's no need to obtain climate data if you already have, I would suggest, a relatively recent record of a climate trends report that fits your needs for a risk assessment. So what we'd recommend is if that's been completed in the past 5 years or so, and you take a look at it and you see the parameters in there would cover your scope, by all means, please use that data. If your municipality doesn't have that information, it's recommended that you do go forward and obtain new projections and use the activities in the roadmap to help you scope those exercises so you don't have to go down into the weeds in many, many facets of climate data. So it depends on your context, but if you have some recent climate data, you should be fine to leverage that.
Any other questions?
Yes, hi Shelley, hi Glenn. It's Haran from the City of Ottawa in the Water Resources Group. My question is, just for context, Ottawa has experienced some extreme rainfall events and some of these have challenged our systems. Some of these storms are also similar to that July 8th, 2013 event in the GTA. I'm wondering, can the climate portals that you noted in this training session help us predict the occurrence of such events, where they may happen, or on what dates?
Yeah, that's a really important question. And so the answer to that is that's not their specific purpose. Climate models are really designed to balance the processes that are happening in the atmosphere that are ultimately contributing to longer term climate conditions. And so what climate models can provide is an understanding of how extreme rainfall events may change over time and what impacts might occur associated with those, but not on a when or where and how significant or surgical they might be. And that's a very tricky aspect of it. So there's much more uncertainty, I would suggest, if you're looking at a highly convective, localized extreme rainfall event using climate models. So that caveat's important to distinguish. Yeah, good question.
Okay, thank you.
Next question.
Hi, it's Jacob Porter, Climate Adaptation Coordinator at the City of Thunder Bay. In this session, it was mentioned that we have the potential to pick climate projection time horizons based on factors like infrastructure lifespan. Do I need to get climate projections for all future time horizons?
Yeah, that's a great question. And, you know, we really do recommend that you obtain climate data for all of the future time horizons. So that's the 2030s, the 2050s, the 2080s. That takes you out to the end of the century. And this really provides sort of that foundation that can be relevant across all municipal departments for a variety of assets. But we did touch on this a little bit. If you really are only focusing on one asset class and you don't need or sort of intend to share that across other departments, and whether that's just for resource reasons or, you know, this is just a tiny little scope, for example, you could look for at just one horizon. So we gave the example of maybe roads. You might just use that mid-century, that 2050s. But we really do recommend, if you have the resources, you have the time, you look across all time horizons. And it's also just interesting to see how the various trends for each of those climate parameters are changing over time. Are they increasing? Are they decreasing? Are they not changing at all? Is there a little bit of variability between those time horizons? So we really do recommend that you try and capture all of the time horizons if possible.
Thank you.
Next question.
Hi, Shelley and Glenn. This is Manny from region of Durham. Thanks for the presentation. My question is, the region has obtained all the climate projections now, and how do I, as a climate lead, share this information to other departments for the benefit of helping them factoring this climate projection in their design? For example, they may be designing culverts and bridges, so if they know the future storm flows are going to be high, they can design those structures to proper size that's going to serve for the next years. I would like you to suggest the best ways that municipalities can use to train or share the climate information with other departments.
Yeah, that's a great question. You're going to all this work. You want to make sure that you're able to share the information and it's actually being used. And often municipalities have developed climate trends reports in the past, and these reports haven't been widely used within their corporation or shared, or it's working in very siloed sort of manner. So when we're talking about mobilizing climate information, the roadmap recommends that you facilitate, whether it's workshops or meetings, with various departments, or the ones that you know are interested in using this information, and maybe those that aren't even aware they're interested or could use this information to their benefit. So as a best practice, we do recommend that you take the time to sort of tailor or target what types of climate data could be relevant to that department. And you're sort of creating this narrative to help them understand how the impacts of climate change are impacting their department, and then how they can use this data to adapt or become more or less resilient. So you're probably not going to want to bring just 50 climate parameters into a meeting with various staff. You know, you really want to try to walk them through a few key points to start. So when is the data for? Is it for the 2050s? Is it historical? What future time projections, and perhaps just a couple examples of those key climate parameters that are really going to be impactful for, say, finance or whatever department you're chatting with. So the climate trends are really relevant and can be used for all departments. It's really just about tailoring that message to make them realize this information is useful, and then telling them how they can use it or how they can start putting it into planning, design, and operations. So it does take some time and communication, but they're really important conversations that you need to be having across all of the departments. So that's a great question. Thanks, Manny.
Thank you very much.
Wonderful. Well, that wraps up our session, everyone. Thanks very much. Our next training session will be on step 4, and then the following is step 5 and 6, and that will wrap up all of our training as part of this workshop series. So thank you, everyone.